Hello, welcome to the course Big Data Analytics. First, we will see what are course outcomes and what are the modules are going to be covered. This course is almost common to all the computer science and allied branches, including PG courses. For example, here BTech, BE, Computer Science and Engineering, Information Technology, AI and ML, AI and Data Science, IoT, Cybersecurity, Computer Science and Business Systems, all these UG courses related to Computer Science and Engineering. Then ME or MTech, CSE, then MTech, AI and Data Science, etc. For all these courses, almost 90% of the syllabus is same. By keeping all these here, we design the syllabus for big data analytics. Let us see. So upon successful completion of this course, as a learner or student will be able to understand the processing large data sets in Hadoop framework and apply MapReduce architecture to solve real world problems. Second outcome, develop script using Pig framework over large data sets and query using Hive framework. The next outcome, understand the fundamentals of Spark and the Scala programming. The next outcome, expertise in using resilient distributed data sets, that is RDD, for creating applications in Spark and query using Spark SQL. Final outcome, understand NoSQL databases and develop data models using MongoDB. MongoDB is one of the NoSQL database. These are all the outcomes a learner or student will be able to achieve after completion of this course. Then coming to the modules divided into 5 parts or 5 units. So what are the topics going to be covered? So as part of module 1 or unit 1, first, what is big data? Here, why big data is important, then when to consider big data as a solution for solving problems, then some of the real world big data use cases. Here, 3 examples are considered: IT for IT log analytics, then the next one is the fraud detection pattern, then social media pattern. After that, the Hadoop distributed file system, which is called as HDFS. Here, first the design of HDFS, then some of the HDFS concepts, that is blocks, name nodes and data nodes, block caching, HDFS federation, HDFS high availability. Then the command line interface, here basic file system operations, then under Hadoop file system interfaces, then in data flow, the flow of file read and file write, which is called as anatomy of a file read and anatomy of a file write. Then the next concept in unit 1 or module 1, MapReduce. Here first, what is MapReduce? Then architecture of MapReduce, followed by how MapReduce works. Here, anatomy of a MapReduce job run, which consisting of the following tasks. First, job submission, then job initialization, then task assignment, then task execution, then progress and status updates, then job completion. These are all the various functionalities or tasks available in MapReduce job run for running a simple MapReduce job task. This will call it as anatomy of a MapReduce job run. Then here, as part of continuation of how MapReduce work, next failures in MapReduce. Here the failures are divided into with respect to task, which is called as task failure, then application master failure, then node manager failure, then resource manager failure. Then MapReduce types and formats. Here first MapReduce types. We are having the default MapReduce job run. Then we are having input formats, which consisting of input splits and records, then text input. Then output formats, which consisting of text output. Finally, developing a MapReduce application. Then coming to Unit 2 or Module 2, so here it covers two frameworks. One is Pig and another one Hive. These are all developed by Apache Foundation. That's why we call it as Apache Pig and Apache Hive. So Apache Pig framework, first installing and running Pig, then an example with that how to generate examples, then comparing Pig with other databases, then Pig Latin, then user-defined functions, then data processing operators, then pig in practice. Then coming to the next concept, Apache Hive. Here, how to install, then what is the Hive cell, then example, then how to run Hive, then comparison with the traditional databases, then Hive query language, tables, querying data, then user-defined function. There are two variants, writing a user-defined function, then writing a user-defined aggregate function. Then the third unit, that third module here, introduction to Spark. Here, what is Apache Spark? Here, first history, then the present and future of Spark, then how to run Spark. Then a gentle introduction to Spark here, Spark's basic architecture, including Spark applications. Then Spark's language application programming interface. Then Spark's APIs. Then how to start Spark. Then the Spark session. Then data frames, here it contains partitions. Then transformations, here it contains lazy evaluation. Actions, then Spark UI user interface. Then an end-to-end example here, data frames and SQL. Then Spark's tool set here, running production applications, data sets, type safe structured APIs, then structured streaming, then machine learning and advanced analytics, then lower level APIs, then Spark R, then Spark's ecosystem and packages. Then coming to Unit 4 or Module 4, here Spark's SQL. Here first, what is SQL? Big data and SQL with Apache Hive combination, big data and SQL with the Spark SQL combination. Here Spark's relationship to Hive. Then how to run Spark SQL queries, then how to define catalog, then how to create a table, then how to apply views, then databases, then select statements. Then next concept is data sets. Here, when to use data sets, then how to create data sets, then actions and transformations applied on data sets. Then another concept, resilient distributed data sets, which is famously called as RDD. First, introducing RDDs, how to create RDDs, how to manipulate RDDs, transformations and actions applying on RDDs, then saving files, caching, checkpointing, then pipe RDDs to system commands. Then finally, the module 5 or unit 5, here the first part, NoSQL databases. Here first reviewing traditional databases, then what is the need for NoSQL databases, then what is columnar database, then what is the concept of failover and reliability principles, then the CAP theorem, then differences between SQL and NoSQL databases, then working mechanism of MongoDB is one of the NoSQL database. First, overview of MongoDB, advantages of MongoDB, environment of MongoDB, data modeling, create database, drop database, create collection, drop collection. Then data types, then insert, query, update and delete operations, limiting and sorting records operations, indexing operation, aggregation operation. These are all the some of the concepts related to MongoDB. So these are all the concepts divided into 5 modules or 5 units. So for all these modules, the prescribed textbooks. So the first one is Tom White. The title is Hadoop, the Definitive Guide, latestly 4th edition, orally published. The first unit 1 and 2 or module 1 and 2 will be covered from this. Then Bill Chambers, then Jahiria, Spark the Definitive Guide, again 4th edition, same publisher, Orally Media, 2018 latest version. The module 3 and 4 or unit 3 and 4 are covered from this reference. Then there are some suggested reading. Directly we are having official MongoDB So as part of module 5 or unit 5, we are having NoSQL and MongoDB. This is the official website. Here you will get the entire documentation related to NoSQL and MongoDB. Even some other resources also, tutorials point, Java point, etc. for easy understanding. MongoDB is the official website. These are all the references and some of the suggested readings. These are all some web resources also available. So, including Coursera, NPTEL, cognitive classes, even some Edureka, then data stacks, etc. Some of the well-known web resources for big data analytics course. Okay, now in upcoming lectures, now we will see module-wise or unit-wise lectures. So stay tuned for latest updates.